Okay, adding and subtracting rational expressions. We're going back to middle school, maybe even elementary school, with the idea of a common denominator. And we want the least common denominator just for efficiency's sake. There are plenty of numbers we could use. We want the smallest one so that we don't have to do as much reducing later on. Because the bigger we make it, the smaller it's going to have to be eventually again. So, without a calculator, what's the first number that 2 and 7 both go into when they get bigger? Okay, well, it's obviously 14. So we want to rewrite both of these as 14 on the bottom. So we ask ourselves, what do we have to do to make 7 into 14? And that's times 2. So whatever we do to the bottom, we must do to the top. That gives us 6. 2 times 7, so 1 times 7, and that's 7 fourteenths, which gives us a grand total of 13 fourteenths. Okay? Now, you might go, oh, 6 times 4, that's 24. And you can do that. You can make both of these 24. I'll do that real quickly. That's 6 times 4, so that's 20 24ths. And 4 times 6, so that's minus 6 24ths, which gives me 14 24ths. But now I have to reduce that by 2 and get 7 12ths. Well, since 6 and 4 both go into 12, why not go there directly? 6 times 2, so 5 times 2. 4 times 3, so 1 times 3. And now 10 twelfths minus 3 twelfths is 7 twelfths. So it's not wrong if you don't recognize the least common denominator. The most important thing is a common denominator. But you want to try to find the smallest for it to be most efficient. So we're going to do the same thing, just with more complicated stuff. Now, 16 and 12, not as complicated, but you may not know off the top of your head, and you just take a calculator, do 16 plus 16 plus 16, and write down a few of these. And then 12, and 12 is 24, plus 12 is 36, plus, oh, there we go, 48. And now we even see it's times 3 and times 4. So if we're making both of these 48, oh, we're not even adding, sorry, we're just finding the common denominator. Crazy what directions tell us. So our LCD is 48. 3x and 9x squared. Okay? Well, first let's look at the numbers. 3 and 9. What do 3 and 9 both go into? Well, quite simply 9. So that's our number portion. And then x and x squared, what do they both go into? X squared. Now, both numbers go into 18 and 27 and 54 and 108, all these things. But we want to try to get the smallest number, which is 9. And x and x squared both go into x cubed, and x to the 5th, and x to the 3049th. But we want to go with the smallest one possible, and that's x squared. Now, x minus 2 and x squared minus 4. What do we do here? Well, let's look at x squared minus 4 first as x minus 2, x plus 2. Well, that means this one has an x minus 2, and so does this. But this one has an x plus 2, and this does not. So we need the LCD to be x minus 2, x plus 2. And we'll talk more about how that affects the problem itself later. 2x plus 1 and x plus 1. Well, we can't just put a 2 in front of here. That's a big no-no. Can't do it. Can't just throw numbers around. Not a magician. So it's kind of like when you have two prime numbers. Like if we had, say, 5 and 7. Well, 5 and 7 have no common multiples until you get to 35, which is 5 times 7. This is the same concept here. It's just going to be 2x plus 1 times x plus 1. So let's think about it. Let's go back up here with the 6 and the 4. We could have gone to 24, like I said, which is 6 times 4. That's a very easy way to find a common denominator, is just multiply them. But there was a smaller one. Same thing here with 16 and 12. We could have multiplied 16 times 12 and got a huge common denominator. But we didn't need to because 48 was more efficient. Well, in this case, 2x plus 1 and x plus 1 have nothing else in common except for multiplying the two of them. So let's move on. Steps. First, you're going to factor, like we did up here with x squared minus 4. Then you're going to multiply the top and bottom by whatever is needed to get that LCD. Remember, we got to do the same thing on top and bottom because that's 1. And that's the only way we can change the expression. Then you're going to write the LCD once, distribute, and combine like terms, and finally simplify. Okay, this is going to be the same problems you have in your paper, but I have it spaced out differently just so I have enough room with the smartboard to get your answers in here. Okay, so to start off, we need to factor the bottom, and this is going to be x plus 3, x minus 3. And over here on the second fraction, we're going to do pull out 2 and get x plus 3. Well, if you notice, they both have an x plus 3. What they're missing is a 2 and an x minus 3. Because we want our LCD to be 2 times x plus 3, x minus 3. So what you do is you look and say, hey, the left fraction, what's missing? Well, I have x plus 3 and x minus 3. I just need a 2. So I'm going to multiply by 2 over 2. The right one is missing an x minus 3. So that's what I'm going to multiply by, top and bottom, because that is 1. I'm not really changing anything, just the looks of it. So on the top, on the left, I have 2 times 6, which is 12. Plus, on the right, I have 5 times x minus 3. Over the common denominator, the LCD of 2, x plus 3, x minus 3. Now, I always want to keep the bottom factored, but I'm going to clean up the top. So I'm going to distribute this 5 and get 12 plus 5x minus 15 over 2x plus 3, x minus 3. And now I'm going to join like terms and basically end up with my answer of 5x minus 3 over 2x plus 3, x minus 3. And that's your answer. Now a couple things to think about. On the 5x minus 3, the 5 and the x are together, so you cannot cancel the x minus 3's in that answer because it is an x minus 3. It's 5x minus 3. Also, at the beginning, up here, some people might think about canceling those x minus 3's. You cannot. Because remember, the 5x plus x minus 3 is attached to the 12 by addition, and we cannot cancel across plus or minus. Think about it. We had an example in 5.1 where we ended up with an answer like this, 9x minus 3, and some people wanted to cancel the 3 and the 9. You cannot. Remember, this x minus 3 is in a protective bubble of the parentheses. Well, similar thing here. This 12 plus 5 times x minus 3 is all one group in that protected bracket that we didn't draw. So just don't, you might be tempted to do canceling like that, but you can't. Number 6, factoring x plus 6, x plus 4. Over here, x plus 4, x minus 1. So my LCD on this problem is going to be x plus 6, x plus 4, and times x minus 1. Now you just ask yourself, hey, what's missing on the left one? I'm missing an x minus 1. So I'm just going to multiply by x minus 1 over x minus 1, and that will work out. The right side, what am I missing? I'm missing an x plus 6. So that's what I'm going to multiply by, top and bottom, x plus 6 over x plus 6. Now, what does it give me? X minus 1 times x minus 5 minus 4 times x plus 6 all over x minus 1, x plus 6, x plus 4. Now, you may have noticed there's a lot of writing going on here, and if you can pay attention, especially if you write up the LCD at the beginning like this, it'll help you keep straight. I have no problem with you not writing the denominator every time, every step along the way. You just got to remember to put it in at the end. So if you can't remember that, write it out each time. But for example, I'd go, well, now I'm going to FOIL and distribute on the top, so I'm going to get x minus 1 times x minus 5 leads to x squared minus 6x plus 5. Now if I distribute the negative 4, I get negative 4x minus 24. And like I said, I should write that all over those three binomials, but if I want to clean it up first, I can just do that and get x squared minus 10x minus 19, and now that I'm cleaned up, I can put x minus 1, x plus 6, x plus 4. And that's my final answer. But like I said, if you need to, whoa, did not mean to do that. I meant to grab this. That was fun. If you need to, for keeping it straight, if you need to write all those here again each time along the way, go ahead. I'm not suggesting a shortcut if it's going to confuse you. But I'm just telling you, you could save time. Like you could not write it here, not write it here, as long as you remember to put it in at the end. Because it is a lot of writing on these problems. Okay, number 7. What's my LCD? Well, I got to factor first. This is going to be x plus 6 and x minus 1. So, what's missing? Basically, on the left side, I'm just missing an x plus 6. Right side's fine. So, on the left side, I get x plus 6 times x plus 2 minus 14 all over, well, x plus 6, x minus 1. And now I'm going to clean up the top by FOILing, and I get x squared plus 8x. Remember, it's going to be 6x plus 2x, which is 8x. You can FOIL right here, FOIL off to the side, plus 12, and don't forget this minus 14. Combine like terms, I'm going to get x squared plus 8x minus 2. Now I remember to put in my LCD at the end. And there's my final answer. Number 8. My LCD is pretty simple. It's going to be 3x squared. So, I need to multiply the 1/3 by x squared over x squared. I need to multiply the 3x, 3 over x, times 3x over 3x. And on the last one, I just need to multiply by 3 over 3. Now, if it gets too confusing with it, when you have 3 like that, you can do it like this. multiply the whole thing by 3x squared over 3x squared, then you just have to go through and think about what's canceling. Like on the first one, the 3 is going to cancel. And on the second one of the x is going to cancel. And on the third one, the x squared is going to cancel. But that's up to you. So what we end up with here is 1 times x squared is x squared, plus 3 times 3x is 9x, minus 4 times 3 is 12, all over 3x squared. And that's as far as we can go on that one. That's it. Last two. 9 is kind of tricky. There's a few different ways you can approach this one. They look alike, don't they? X minus 2 and 2 minus x. But really, if you think about it, this is negative x plus 2. It's not the same thing. It's not the same thing. So what we need to do is make them the same thing. So I could, this is one way to go about this, I could pull out a negative 1 and make this x minus 2. Which means all I need to do to say is my LCD is negative 1 times x minus 2. And now I just need to multiply this one by negative 1 over negative 1. And what that gives me is negative 1x plus 7 over negative 1 times x minus 2. And I could leave it like that. I could also, if I want to clean it up a little bit, say the top is really negative 1 times x minus 7 over negative 1 times x minus 2, and my negatives 1 cancel. So I just end up with x minus 7 over x minus 2. That answer would be fine. This answer would also be acceptable. But if you want to clean it up, you could. Another way to go about it is, since the negative can be in the top or the bottom, you could approach it like this. Effectively, I'm doing the same thing, just a little quicker. I'm pulling the negative 1 out of the bottom, this negative 1 right here, and I'm setting it to the top. And really, I'm going to get the same answer right off the bat. Obviously, a lot quicker, but a different way of thinking about it. So it's whatever works for you. But all I did was I did the same first step here. I took the negative 1 out, but instead of making the left side match, I just moved the negative to the top, because it doesn't matter if the negative is in the top or bottom of the fraction. And by making that minus 7 instead of plus 7, I get right to my answer. So, multiple ways, but do what you like. Okay, this one, last one, you're going to pull 3 out and get 3x plus 5. So my LCD, this is a really good first step, is x minus 2. I'll put the 3 out in front, times x plus 5. I'm going to put the 3 in the middle, doesn't matter. 3x minus 2x plus 5. So what is my left one missing? Well, it's missing 3x plus 5, 3x plus 5. The right one is missing an x minus 2. And now I multiply. I multiply effectively, would skip this step, but I'm doing 3 times x plus 5 times 2x. So it doesn't matter what order you multiply these by. You can send the 3 in or multiply 3 times 2x. It doesn't matter. You're just going to multiply all of them. So that's 6x. So times x, I'm going to get 6x squared plus 30x. Like I said, I'm just showing you this step in the middle because it doesn't matter which way you multiply them. Any order will do. So it's 6x squared plus 30x, and then the minus the 3 times x minus 2. Again, all over 3, x minus 2, x plus 5, if you want to write all that. Now I'm going to send the negative 3 in and get 6x squared plus 30x minus 3x plus 6. Negative times negative is positive. I'm going to clean this up and get 6x squared minus 27x plus 6. Now, you might think, hey, I'm done. Write the denominator. No, because these all have a 3 in common. I'm going to pull a 3 out and get 2x squared minus 9x plus 2. Now, I'm going to write it all over my 3, x minus 2, and x plus 5. And why did I pull that 3 out? Because look what happens there. The 3's cancel. And my answer is right there.